Good morning. We have now come to the third appointment here at the Xilexpo. Third appointment with Kata's laboratory. In the past few days, we've talked about wood. Yesterday, we talked about timber panels, and today we're going to focus on the materials and technologies to coat panels to then be assembled in the pieces of furniture that we all have at home. So the topic of surface finishes and coatings includes the different types of materials that we're going to look at in a short while. And it also includes varnishes, varnish coatings. And this is maybe the most complex chapter in the woodworking industry. Why complex? Because we have many different types of surface finishes. There is a lot of variability, and these materials are then in turn subjected to some processing when they are produced and also when they are applied to timber panels. There are gluing processes that can be very critical depending on how different materials are combined. And then there are additional operations and treatment, such as surface sanding for a veneer layer, and this comes prior to varnishing. And varnishing and coatings can then be applied to impregnated papers on plastic layers. So there is a lot of complexity that goes from the production of the material itself and then ends up in the practical utilization of the materials in the furniture. This complexity has very few references in the furniture industry too, in terms of knowledge. As Kata's lab, we are now very committed to running tests, but also to delivering education. And one of the top subject matters that the manufacturers require us to focus on is really coating materials and varnishing materials. So we are very busy with companies and businesses to try and share our knowledge on these materials. What are they, after all? I already hinted at some of them earlier, like timber veneer, so thin timber sheets, which can vary. For example, this is a veneer layer on its back. It's glued to another reinforcing materials, and this can be used when you apply it to bending surfaces. Within the area of veneers, we also have these beautiful materials. These are called multilaminar veneers. They can imitate, mimic traditional wood species, but they can also reproduce different patterns. You need to be careful of the differences between natural material and coating materials that do derive from wood, but in order to get to this appearance, it had to undergo some treatments. And then there is the whole area of cellulose-based materials. They start from impregnated papers. They are then printed, and then they are dipped into resins that impregnate them to fill all the porous gaps of the medium, or laminated could be CPL laminates with 2 or 3 layers of impregnated papers, or other types of laminates with higher performances, such as the HPL, high pressure. Anticipated within each family, there may be variables for impregnated papers. We have a pre and post impregnated There's HPLs come in pre and post shapeable ones. It's a whole world that we need to become knowledgeable about, and CATAS is available to deliver this knowledge. And then finally, in terms of coating materials, we may have plastics too. This is PVC, but at present day we encounter more and more often plastic sheets, PET-made plastics, which replaces PVC, or very much polished surfaces in polymethyl acrylate. So there is a basic knowledge that it's always needed and appropriate to have. And finally, there are also varnishing applicable products or coatings. Of course, as we know, varnishes are liquid products. They can be applied through different technologies and techniques. And in this case, too, there is a variety of different products and technologies. We may have the solvent or water-based products, UV varnishes, or polyurethane bicomponent finishes. Lately, there is also the possibility to do varnishing with XE So there is a whole world to be discovered in this area too. It is very varied with a lot of facets to be studied, and CATAS can provide help in getting familiar with all these options. When we go to our laboratory, of course, there is a need to characterize these materials, to prepare tests and verify the performances of these materials. And this is very important to understand whether a product or a material is suitable for kitchen surface tops or a living room surface or an office furniture surface. All the tests will be presented by my colleague Claudio Caon, who is in charge of the surface treatment part of the laboratory, and all the tests are meant to verify the suitability of a certain material to its use. We are now in the surface finish department. As anticipated, I am going to give you a short overview of what we do on a daily basis in this department. We evaluate the resistance and the performance of surface finishes, and we simulate their use in households, in offices, and also in outdoor environments. The end user will then receive evidence about the specific performance and resistance against the different parameters. One of the most required ones is to test the surface finish performance in the presence of liquid spills on the surfaces. Classic example is a kitchen top surface where I have different substances that we can reproduce by standard, like tea, coffee, and water. They are deposited for a certain amount of time, and they are later removed. And the effect, the visual effect, is then rated on a scale from 1 to 5. The same criterion can be used to evaluate resistance to heating bodies. In the kitchen, for example, anything can happen, especially on a work surface, and we can simulate the effect of a pot resting on a surface, and this may lead to sometimes irreversible damage. For varnish coating, the requirement is to resist and withhold the transportation effects and to temperature sudden changes. There are standards that require to run climate changes going from -20 degrees to +50 degrees, and at the end of this cycle cycles, you can then evaluate defects, ruptures, and other aspects. A final user that buys pieces of furniture expects the color of the wood the furniture is made with to be stable over time. And one of the tests that we conduct here at CATAS is to test the surface resistance to sun rays. There are machines that are equipped with xenon lamps. Xenon lamps simulate the sunlight. You can see a few examples here. Ashwood here has changed its color tone. Standards clearly indicate how to run these tests. Other characteristics that are commonly requested to be tested refer to the varnish coating adhesion to a surface. Oftentimes, due to problems to the varnishing line, to the product or to the process itself, the varnish coating is not adequately adherent to the surface. Here at CATAS, we run pull-off tests for surface adhesion according to international methodology. We etch the varnish film and then we pull it off with an adhesive tape, and finally we evaluate the quantity of removed varnish. Other tests that we carry out to characterize surfaces of shelves is the test of dirt retention. White, soft-colored surfaces with a soft touch appearance that is very pleasant to touch are hard to clean, and these surfaces may suffer residual damage after the surface has been contaminated with dirt. The user tries to clean surfaces using aggressive detergents, but the damage is already there. So the recommendation is to test the surfaces, especially the clear ones, the soft-colored ones, by relying on a standard, that is to say, using a rag to spread some coal black and causing a stain like this one, and then trying to clean it by removing it and evaluate the residual effect. This is a case where the surface can hardly be cleaned. Other tests may be applied to edge bending processes. A chipboard panel is always covered with some edge bending that it's glued in different ways. There is a UNI test in this case, according to which the edge bended panel is set to different climate exposure, from 40 degrees up to 90 degrees. There is a visual assessment of how the panel responds. In this case, we can observe that after a relatively low temperature, the adhesive part has collapsed and the edge is out. This is the aging area. We are standing in front of a climate cell, which we use to run temperature sudden changes tests. We can see here that there is a panel at the end of the test. This multi-layered panel, varnished, presents some ruptures of the varnish. Due to a sudden temperature changes, the varnish coating was not able to bear the tests and got broken. We are now in front of the xenon test. This is a test used to evaluate resistance to light. We use a xenon lamp which simulates sunlight. The absorption emission spectrum is similar to that of the sun. The sample is covered up half and the upper part is exposed. The change here is very noticeable. Wood is ashwood, pre and post sun exposure. This is a rubbing test. The rubbing test is performed by moving a swab of felt up and down. We rub it on the surface, and this test is useful to determine resistance in handles, for example, handles with galvanic coatings or with varnish finishes. And you can see this handle suffered damage through rubbing test. The client then changed the varnishing cycle and was able to obtain a better performing resistance. This is a salt spray chamber. The test is conducted to measure resistance of metals to corrosion. This is a water and salt atmosphere, and this is a sample of a hinge that passed the test. In some cases, however, the test will not be successfully passed. We can see a few examples of that. When we speak about wood panels, most of the times these are trimmed or coated varnished panels and never raw panels. In the case of varnish panels, it is important to consider the long-term emissions coming from that panel in the long run. CATAS has been working technically and standard-based to verify all the substances that are released by the timber-based panel in order to provide added value in terms of safety. In order to do this, we rely on technologically modern chambers where we introduce small pieces of wood panels that simulate the finished product that lands at homes. This is the cell dedicated to determine volatile organic compounds in timber-based panels used for furniture supplies. There are different slots in this room. Each slot has 8 positions where we replicate the conditions of households. Wood panels stay in here for 28 days, and upon day 28, the engineers will take a sample of a few liters of of air, and they sample a few liters of air, and on this sample they can determine exactly any type of substance that the panels have released. The final result is then matched with the law prescribed thresholds or specifications. I think it's important to specify that the determination of volatile organic compounds is a recent requirement. The quality of living environments has been valued even more. Households in the past few years have been insulated and sealed due to energy saving purposes, but we've never really considered the accumulation of all the substances that furniture supplies may release inside of home environments. With this type of tests and equipment, this is what we can determine the maximum concentration of substances that we will have in households. So the maximum amount of VOCs. The interest of the market is to create products with a very low release level of VOCs. We have now come to the end of the third day at Xylexpo. This third day was dedicated to CATAS again. In this part of the day, we've looked at 3 different categories of materials, solid wood, wood panels, and today we treated the topic of surface treatment and finishes with some considerations related to pollution or tomorrow we're going to meet again for our very last appointment at this Xilexpo. Tomorrow's main focus will be tools. Of course, we don't test tools here at CATAS. However, we will have something to say about these tools in relation to some woodworking processes or in relation to defects and product characteristics.